I have values that are test scores that aren't already z-scores. How do I convert them to a z-score? Well, we have a formula, and you will be provided with this formula. In fact, if you've got your z table printed off, you can see it across the top of the table. The z-score is just the observation x minus the mean divided by the standard deviation. Okay, so you want to be familiar with this formula. So suppose I have a normal distribution whose mean is 30 and whose standard deviation is 5. Let's start by finding the z-score corresponding to 21, and then let's find the z-score corresponding to 37. So I just want to plug into my formula where these values 21 and 37 are going to be my x. Okay, so I'll find one for 21 and then one for 37. Okay, so on the left is we're just going to draw the whole thing. On the left is the distribution that we're given, right? It has a mean of 30 and a standard deviation of 5. On the right, we're going to use the formula to convert everything to z-scores. So when we convert to z-scores, our mean is now 0. And so let's start by converting 21. We're going to plug in 21 minus the mean, 30, divided by 5. And that gives us negative 9/5 for the z-score for 21. And for 37, we're going to plug in 37 minus 30, all divided by 5, and that gives us 7/5 for the z-score for 37. Okay, so let's try putting it all together. Suppose you take a standardized test, assuming that the distribution of scores is normal and that you got a 72 on the test. Let's suppose that the distribution of all scores had a mean of 65 and a standard deviation of 4. We want to know what percentage of those who took the test had a score below yours. So you want to know how you did compared to everyone else. All right, the first thing we're going to do is draw a picture. So I have my normal distribution drawn here. I'm going to label my mean. My mean is 65. And I'm going to label the value that I'm interested in. Here, it's the observation x equals 72. That was my score. And now I'm going to shade the area that I'm interested in. I want to know what percentage of those who took the test had a score below mine. So I'm going to shade everything to the left of 72. This is the area that we want. Now remember, my table gives me areas between the means, and in the standard normal distribution, the mean is 0. So between 0 and the z-score. Okay, so if I think of, after I convert this to z-scores, I'm going to have to cut this down the middle here. And I'm going to want to find this area to the right. So that's one area that I'll be able to find in my table. And then this area to the left. Now this area to the left you should be able to tell me already, actually, because it's just everything to the left of the mean. We know in any normal distribution that the mean is equal to the median. So the area to the left of 65 is just 0.5, right? Half of the data is to the left of the mean, and the other half is to the right. So the real work is going to be finding this red shaded area. Okay, so the next step is to find the z-score for 72. So we plug in to our formula, and here's our z-score. So 72 minus the mean, 65, divided by 4 gives us 1.75. Now we want to use the z-score to find the area that we want. So take out your table and look for a z-score of 1.75. Okay, so again, you're going to look for 1.7 down the first column and 0.05 across the top and find where they meet. And you should find that they meet at 0.499. 0.4599. I apologize. Okay, so that means that the area to the left of 1.75, well, it's this area that we had shaded red, and now all of a sudden I'm making orange. Let's switch to red. Okay, so this red shaded area, which we just found in the table, right? You looked in the table, and this area was 0.45, my goodness, 99. And we said last slide that this area here, to the left of the mean, is 0.5. And so if I want the whole shaded blue area, I need to add those together. And so that's what I've done here. All right, so when I add them together, I get 0.9599. So there are 95.99% of the scores below a 72. So you did pretty good, right? You scored higher than 95.99% of the other students. All right? Let's look at another example. So here the scores of high school seniors taking the SAT in 2015 are approximately normal, with a mean mathematics score of 511 and a standard deviation of 120. The mean critical reading score was 495 with standard deviation 116. What proportion of students scored above 392 on the mathematics portion of the SAT? Okay. All right, so step one, you should know by now. We're going to draw a picture. All right, so we're going to draw a normal distribution, and we're going to label our distribution. So I've already converted to a z-score here. Let me just sketch down here before I converted to a z-score. Whoops. What we would have drawn. So the picture looks the same, except the scale would be slightly different. The mean is what? The mean math score was 511. And the standard deviation was 120. And we want to know what proportion of students scored above a 392. 392 is to the left of 511, so I'd mark the 392. And we want the proportion that scored above, and so that's why we've shaded this blue region here. Right. All right, now again, this blue region isn't exactly what the table gives us. So we'll want to figure out how to use the table, but before we can use the table, we need to get a z-score. So let's plug into the z-score formula here. So go ahead and plug that into your calculator. And you should get negative 0.99. All right, so now I'm going to break it up into areas that I can get from the table. Remember, the table gives us areas between a z-score and 0. So let's cut this through the mean again. Okay. And so I'm going to break it up into two areas. The area between negative 0.99 and the mean, 0. And the area between the mean and everything to the right. So that's two areas that I'm looking for. The orange one, let's go back to orange, is this first area that I'm going to find in the table. And I need to add it to the red. And the red, again, is one that we know, right? If we're just going to everything to the right of the mean, that's half of our data. So this red area we know is 0.5. Okay, so step 3 is to use the table. All right, so we're going to go to the table and we're going to look for our z-score, but our z-score is negative, right? So remember, since the curve is symmetric, we can look for positive 0.99, and that'll give us the same area that we need for the negative 0.99. So here's my table. I'm going to look in the left column for 0.9, and I'm going to look across the top for 0.09, and where they meet is here at 0.3389. Okay, so the area from negative 0.99 to 0 is going to be 0.3389. So when we add that to the area that we had, oh no, let's go back here. Okay, so when we add it to the right area from 0 to the right, we got 0.8389. Okay, so again, we got that this area was 0.33, oops, 89, and this area was 0.5. And so since we want the sum of those two areas, we're going to add them. All right, so again, what does this represent? This represents this area. It's the proportion of students that scored above a 392 on the mathematics portion of the SAT. So my last step should be to go back to the question and answer it. Okay, so we wanted to know what proportion of students scored above 392. Well, we just found it. About 83.89% scored above 392. All right, you try on your own what percent of students scored between 392 and 650. All right. Again, you should follow these 4 steps. Start by drawing a picture, then find the z-score. In this problem, you're going to have 2 z-scores, one for 392 and one for 650. Try to separate your picture into some pictures of things that you can find the areas for. So in our case, we had 2 and we added them together. Sometimes you might need to subtract. And then go to the table. All right, so go to the table, find the areas that you're looking for, and finally conclude. All right, so go ahead and pause the video and try to answer this. Keep your notes so that you can turn them in on Tuesday. All right, so now that we know how to find the percent of values that are within a certain range, what if we want to answer sort of the opposite question? So say I know what percent I want, and I want to know what value hits that percent. Okay, so here's an example. I know that the SAT combined math and reading scores follow a normal distribution with mean 1006 and standard deviation 209. I want to know how high a student has to score to place in the top 10% of all students taking the SAT. Okay, so the percentage I know is I want the top 10%. So again, we're going to start by drawing a picture. So here's my normal distribution. And the top 10% is that yellow shaded area. Okay, so 0.10 is the area for 10%. All right, so I know that I want to know what that z-score is. All right, I want to know what z-score gives me an area to the right of 0.1, but the table tells me just the area between 0 and the z-score. So in this case, it would be this area. And so if the whole area from 0 to the right is 0.5, and I know z has 0.1 to the right, then that means between 0 and z, it must be 0.5 minus 0.1, which is 0.4. Okay, so I'm looking for the z-score that gives me an area of 0.4 in the table. Now in your table, the areas are the numbers that are in the middle of the table, right? The z-scores are given in that first column and top row, and then these numbers inside are the areas. So I want to look at the table and I want to find the area closest to 0.4. Okay, so here's my table. Look inside the table and we're looking for an area close to 0.4. Okay, so I'm looking in here. I see 3.962, 3.98, 3.997, and now I'm over 0.4. So it's between 3.997 and the 0.4015. That's where 0.4 is. And so I want to pick the one that's closest to 0.4. And the number between those two that's closest to 0.4 is 0.3997. Okay, so that's the number, the area that's closest to 0.4. So I'm going to look up and to the left to find the z-score that corresponds to that. And so you can see that the z-score that I get is 1.28. All right, so our z-score is 1.28. So let's go back to where we were. So that tells me the z-score, but it doesn't tell me the SAT score that I need. So I need to use my z-score equation and solve for x. All right, so here's my equation. If I solve for x, I can rewrite it as x equals the mean plus z times the standard deviation. And I'm just going to plug in everything I know. So 1006 plus 1.28 times 209. And that should give you 1273.52. All right, so this is the value on my distribution that has a z-score of 1.28. And so this is the score that you would need to have to be in the top 10%. Your last step should be to conclude in terms of the problem. So we're just going to say a student must score above 1273 to be in the top 10%. All right, so here's a problem for you to try. Again, pause the video and try this problem. Write down your answers and I'll collect them in class on Tuesday. So for this one, I want to know what are the median and the first and third quartiles of thorax length. Let me get you started here. So the first step is what? Always draw a picture. So let's draw a picture. So we want a normal distribution. And I want to find the first and third quartiles. So what do we know about our normal distributions? The mean, I'm going to give you the answer to part of this. The mean is always equal to the median. So finding the median should be really easy when you know your distribution is normal. It's just equal to the mean, which in this case is 0.8. Right? Now the quartiles are a little trickier. So Q1, oh my, and Q3 are what I'm looking for. And you're going to have to do them separately. Think about the standard normal distribution. First, we're going to have to find the z-scores. So a mean of 0, and here let's call this z3 for Q3. All right. What do I know about the quartiles? They break my data into quarters, right? So what that means is that the area between 0 and z3 must be 0.25. It cuts that half in half again. Okay, so you're going to look in your table for the z-score that has an area closest to 0.25. And then you're going to have to come back and use the formula for z-score to convert it to an x value. All right, so I'm going to leave you with that, and you go ahead and pause and work on this problem.